Hi everybody. In this playlist, we are going to be focusing on the operations on rational expressions. We're talking about addition, subtraction, multiplication, and division. In this particular video, by the end, I hope you know what rational expressions are. We're going to review rational numbers, see how those are going to be connected up with rational expressions, have some examples and non-examples of rational numbers. We'll define rational expressions and polynomials, and we'll have some examples and non-examples of rational expressions. So first here, reviewing rational numbers, let's remind ourselves of the definition. A rational number is a quotient or a fraction of two integers where the denominator is not zero. Have you ever wondered why we can't divide by zero? Well, here's one way to think about it. So if we're looking right here at the fraction or the quotient, 15 divided by 3 is equal to 5. Now, if we multiply both sides by 3 there, we'll have 15 is equal to 5 times 3. So that means that when we multiply 3 by 5, we get 15. And now, extending what we just said to here, where we're dividing by 0, that means that if we multiplied both sides by 0, we would have 6 is equal to x times 0. And that should be a problem, as you see. What could we possibly multiply by 0 and get 6? There is no such thing. That's why when we divide by 0, we have an undefined value. There is no such value. All right, so rational numbers, examples and non-examples. So 3/4 is an example of a rational number. In the numerator, we have 3. In the denominator, we have 4. Those are both integers. We have -2/7, -2 in the numerator, 7 in the denominator, both integers. Now here we have 4. How is that a rational number? Well, it doesn't have to be written as a fraction, but it could be written as the fraction 4/1. Therefore, 4 is also a rational number. Here we have square root of 4. And again, that looks kind of weird, having a square root of a number, but square root of 4 is 2, which could be written as 2/1. And there we see that square root 4 can be rewritten as a fraction with an integer in the numerator and denominator. So next, we're going to look at non-examples. Square root 3 is a non-example of a rational number. There is no fraction that represents square root 3. If we write square root 3 as a decimal, that decimal would never repeat and would go on forever. So it cannot be written as a fraction. Here we have square root -4. And whenever we have square root of the negative number, it's going to be I, the complex number I, involved. So here we could rewrite that as square root 4 times I, and that could then be rewritten as 2I, but I is not a rational number. It's not an integer, so it can't be included in the rational numbers. Pi is like square root 3. It is an irrational number, can't be represented as a fraction. Its decimal value goes on forever, never repeating. And we already talked about why 0 in the denominator cannot be a rational number. So here we have two definitions. First, we have a definition of a rational expression, which is a quotient or a fraction of two polynomials with a non-zero denominator. So again, like rational numbers, it's a quotient or a fraction. And this time we have a polynomial in the numerator and the denominator, no zeros in the denominator. Since that definition includes the term polynomial, I want to give the definition of a polynomial here. It's an expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication, and non-negative integer exponents of variables. So let's look at some examples and non-examples of rational expressions. Here we have a polynomial 3x plus 4 in the numerator and a polynomial 4x squared minus 7 in the denominator. In the next one down here, negative 7x, that's a monomial, which counts among the polynomials in the numerator, and a polynomial in the denominator. Now you might look at this and think, wait a second, we can't have those negative exponents, and that is true. However, we could rewrite this as 1 over 4x squared, and that works just fine as a rational expression. And this one, I'll be honest, it threw me off this morning when I was thinking about it. We've got an irrational number, square root 7 here, as a coefficient of x. However, that is still a rational expression. So we have an irrational coefficient in a rational expression. Fun to wrap our minds around stuff like that. This one here is a non-example because down here we have x minus 5 minus the quantity x minus 5. And if we do that subtraction, we have in the numerator x minus 3 over 0. And that is not a rational expression. In the next one, we have 2 to the x. That is not a rational expression because we cannot have variables in the exponents. If we had x squared, that would be just fine, but 2 to the x and x squared are totally different things. So 2 to the x is not a rational expression. All right, that was kind of a long video. Hope you stuck with me. Move along to the next video, which is rational expressions multiplying and dividing.